Pantomime, mid-air gesture recognition with the sparse millimeter-wave radar point clouds. This work has been done in collaboration with Samira Palipana, Luis Leiva, and Professor Stefan Sick. Gesture recognition provides a natural and device-free way of nonverbal communication. Human-robot interaction, smart screens in shopping malls, vehicular scenarios, and smart homes are a few scenarios and applications in which gesture recognition can be useful. Radars are robust to lighting and weather conditions as well as cluttered environments in general. Imagine there is a wall on one side of which there's a participant performing gesture, and on the other side we have an RGB depth camera recording the gesture. It's pretty obvious that we won't be able to recognize gestures. But in the same scenario, we can simply substitute the RGB depth camera with a radar, and then we can improve the accuracy up to 65%. Pantomime aims for mid-resolution, mid-range, and small form factor RF sensing. There are a few technologies out there doing RF sensing like MS Kinect, but we are positioning Pantomime in a unique region of RF sensing spectrum. Medium resolution, a range up to 5 meters, and small form factor are the unique features of Pantomime. What do we mean by privacy preserving? Here we have a point cloud generated by the radar for a participant who is performing gestures. As you can see, we cannot see details, we simply see the points. So that's what we are talking about, privacy. Pantomime classifies gesture using neural network-based pipeline. Here we have a two-step pre-processing pipeline. In first step, we perform pre-processing to generate point clouds from dense tensors, and in the second step, we are normalizing the generated point cloud. And for recognizing the gesture, we have a neural network in which we extract spatial features using PointNet++ blocks from each frame, and then we fuse them to capture the evolution, the temporal evolution of the gesture through LSTM layers. And we also have an aggregated point cloud processing pipeline at the bottom to extract more spatial features from the gesture. And at the end of the network, we have three fully connected layers with dropout layers in between to extract fine-grained features. To evaluate the performance of Pantomime, we collected a dataset from 41 participants with 21 classes of gestures, 5 environments, different distances, speeds, and even different angles. Pantomime outperformed state-of-the-art models with a considerable margin. As you can see, on all those 3 sets, we outperformed 5 different state-of-the-art models in terms of 2 different factors or metrics like average accuracy and area under the ROC curve. Pantomime is robust to different environments and articulation speeds. In the left-hand side, we have the results for different environments like open, office, factory, restaurant, and through-wall sensing. As we go toward the environments in which we have a lot of stuff, the accuracy decreases, and the reason is that we have more reflection from the surrounding objects. For medium and fast articulation speed, we have very good results, like more than 92%. But for slow speed, we have like more than 85% accuracy. And the reason is that for slow speeds, the radar generates less points. As a result, the distribution of the test set is different from the distribution of the trained set. How about through-wall sensing? As you can see, we have an accuracy of 64% for through-wall sensing environments. Pantomime is robust to different angles, even extreme ones. As you can see in the blue curve, we have not normalized the angle and also the distance. And as we go to extreme angles like -45 or +45, we have a significant drop in the accuracy. But by normalizing the angle and also the distance to radar, we managed to improve the accuracy even for the extreme angles. And the orange curve shows the accuracy in the test set after normalizing the angles and also the distance. Pantomime performs well in different distances up to 5 meters. As you can see in the left-hand side, we have the accuracy for different distances. When we train the model on only 1.5 meter distance, the accuracy drops significantly when we go to different distances like up to 5 meters. But when we train the model on data from all distances, we managed to improve the accuracy and achieve an accuracy of more than 65% even for 5 meters. And the reason is that when we change the distance, we have to reconfigure the radar. And by doing so, we are changing the distribution of the data in the training set compared to the test set. In conclusion, first we introduced a radar-based gesture recognition platform and we showed that it can outperform state-of-the-art models with a considerable margin. Second, through comprehensive set of experiments, we showed that our system is robust to different settings, even extreme ones. And finally, we published our dataset on Zenodo with more than 12,000 samples to let our other researchers build upon our work and reproduce the results in the paper. And finally, we believe Pantomime can open new doors in RF sensing and can lead to novel applications.